Assalamu alaikum. So these two sample signals are non-identical sample signal. Why? Because if I draw a line here, you will have a clear visualization that these two signals are not same. That means these two signals are non-identical signals. But if you look here, you will see that these two signals are identical signal. You will see that these two signals are same. And why? This is because the behavior of analog frequency of these two signal. You are watching that here analog frequency f2 is equal to f1 plus fs, where fs is the sampling frequency, but here the f2 is not is equal to f1 plus fs, and that's why this is not identical and this signal is identical. So in this video we will derive this condition, how this comes, and then we will see a Python code here where we will change f1 and f2 and see different kinds of signals here, so that you will have lots of example at the end of this video. So let's start. So let's say we have two sample signal here, one is xs naught and another is xsk. Now we will choose omega k is equal to omega naught plus 2 pi k. Why I choose this thing, you will understand it later. So here k is an integer, let -3, -2, -1, 0, 1, 2, dot 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 dot. That means k is an integer, may be positive or may be negative. Okay, now we can write xsk is equal to a cos. Let me write this thing omega naught plus 2 pi k instead of omega k. Okay, and then let me rearrange this thing. Let me write 2 pi k into n here and then omega naught into n here. Okay, and we know that n is a positive integer, 0, 1, 2, 3 dot 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 dot. That means k is an integer, n is also an integer. That means k into n is also an integer, right? K into n is also an integer. That means it might be -3, -2, -1, 0, 1, 2, etc., right? So we know from the property of this cosine function that if you have a integer number multiplied with 2 pi, then we can write this thing as 2 pi omega naught n. Okay, and look carefully, what is this? This is actually xs naught, so I can write this is xs naught. So we can say that these two signals, so we can say that these two signals are same, right? So these two signals are same, that means these two signals are identical. And why these two signals is identical? Because their angular frequency omega k is equal to omega naught plus 2 pi k, and for this relation the two signals are identical. That means if two signal will be identical if omega k is equal to omega naught plus 2 pi k. Okay, now let me write 2 pi f naught instead of omega naught. So omega naught is equal to 2 pi f naught, and again 2 pi f k instead of omega k. So 2 pi f k. These small f's are called digital frequency of that sample signal. Okay, then let's cut this 2 pi, 2 pi, 2 pi. So we will have fk, then f naught, then k. Okay, now you have to remember one thing, what? That we have a analog signal and capital F is called the analog frequency, right? that means this is the frequency of this main signal, and our sample signal frequency is f divided by fs. It's also called small f, which is f divided by fs. So we have to write f divided by fs here. So it is fk divided by fs, and this is f naught divided by fs. Why I write this? Because this formula says f is equal to f by fs. So let me now multiply this thing with fs. So I will get fs is equal to f naught plus kfs. Okay, so this is the condition for which the signals will be identical. Okay, that means fs, this is fk. That means if you have a signal which is f naught, then f naught plus fs, these two signals are identical. Even you have a signal f naught plus 2fs, you can say that these three signals are identical. Even you have a negative frequency, theoretically f naught minus fs, you can say that these four signals are same. So let me see, and if this condition is not true, then we can say that these two signals are identical. So let me go to the Python code here, and let me come here. So f naught is equal to 2 kilohertz, and fk is equal to, let's say, fs plus 1 kilohertz. That means that f naught is not is equal to, fk is not is equal to f naught plus fs. It's different. So these two signal may be non-identical signal. Let's see what happens. Okay, so these two signals may be non-identical signals. Yes, this two signal is non-identical signal because the green one, the green signal and the red signal is not same signal, right? Now let's take f naught fk is equal to f naught plus fs, and let's see what happens. Okay, now these two signals are identical, right? The green signal overlaps over the red signal, so you can't differentiate these two signal. You are watching one signal because these two signals are same. Okay, now let's take here 2 and let's see what happens. Let's see what happens here. Okay, you see the two signals are identical, overlaps each other. Okay, if I take a negative frequency here, let's say it's theoretically negative frequency, let's see what happens. Yes, you see the two signals are identical. Okay, so this video has been ended up. In the next video we will see the Nyquist theorem, for which frequency we can sample these things. So thank you.